In this video, I'm going to solve the ALEKS problem called finding the components of a vector given its graph. This problem is going to give us a vector and ask us to find the x and the y components of that vector. You can see that the vector is starting at the origin of an xy coordinate system. We've got the length of the vector and one of the angles, and we're just asked to find the x and y components. So the x and y components are the distances that you would have to travel along the x-axis and also along the y-axis if you wanted to go from the origin to the endpoint of the vector. It's really helpful if you visualize this as a triangle, because we are going to be using trig relationships to figure this out. So we're going to visualize this as a triangle. I want to point out that it's important to sketch or visualize a triangle that includes the angle that's been provided to us. So I don't want to visualize this particular triangle, even though we absolutely could do it that way. It's going to just be faster and easier for us if we draw the triangle that includes that 51-degree angle. So we're going to sketch that in. Now our job is to try to figure out this side length, this is the y component, and also this side length, it's the x component. So this is just a trigonometry problem. Let's remind ourselves of SOHCAHTOA. This helps us remember the relationship between the sine, cosine, and tangent functions and the side lengths of a triangle. For this 51-degree angle, the opposite side of the triangle is the y component of the vector. This is the hypotenuse and this is the adjacent side. And it's actually not possible for us to calculate to solve for both the x and y component at the exact same time. We have to solve for one at a time. If we were trying to solve for both of them at the same time, we would have two unknowns in the equation, but only one equation, which makes it impossible to solve. So it doesn't matter which one we start with. We could start solving for x, or we could start with solving for y. It really doesn't matter. Let's start with solving for y, and to do that, we're going to use the hypotenuse. We're going to be using the opposite and the hypotenuse side, and that relationship is the sine relationship. So we know that the sine of our angle, which is 51 degrees, not 5 degrees, the sine of our 51-degree angle is going to be equal to the opposite side, or I'm going to write that as the y component of the vector divided by the hypotenuse, which is 91. So doing a little bit of algebra here, letting those 91s cancel out, we can solve for y. With your calculator, before you get into this problem, make sure that your calculator is set to degrees, not radians, because this angle is given to us in degrees, not in radians. And I'm going to just calculate this. 9 times the sine of 51. That is y is equal to 70.72. ALEKS wants this particular one reported to the nearest hundredth. You should always double check and make sure that it's asking for the same from you as well. Oh, this is negative 70.72. Negative because it is down. Down in the negative area of the y-axis, so definitely be careful with that. So now that we have that figured out, we just now need to solve for x. We do know this value at this point, so we could use these two to solve for x, or we could use the adjacent and the hypotenuse. That's the cosine. I'm going to use that relationship. Cosine of our angle, still 51, is equal to a, which is our x component, divided by the hypotenuse, which is 91. Again, we're going to multiply both sides of the equation by 91. And then solve 91 times the cosine of 51. That gives me an x component of 57.27 when I round it to the 100th decimal place.